Like dear students of class 9. So today we'll be starting with new chapter, that is chapter number 5, periodic table. Okay, so today we are going to start with chapter number 5, periodic table. Now you know about periodic table, the modern form of periodic table that you see on your book and that is being used nowadays. But to come to this new modern periodic table, there were so many researches done, okay, now, and which were then at that time they underwent modification, okay, with new inventions and with new discoveries of elements and new properties, and at last today we have modern form of periodic table. Now today we will be discussing about these theories or laws given by different scientists at their own time, okay, based on for these elements. Now we will be discussing today about different laws, okay, for which were used to classify elements in certain pattern. Now the first question comes here: why this classification of elements is necessary? The classification of elements is necessary because it helps in study of different elements in organized manner. It becomes systematic if they are arranged in particular groups or in some columns. Now, it also, whenever they are arranged in certain particular forms, then the study of relationship of elements with each other also becomes very easy. And one more thing that will help in correlating the properties of elements with fundamental properties of matter. So these are the points why there has been classification of elements into different rows and different columns. Okay, so today we are going to discuss them one by one. The first theory that was given by Dovelier. Okay, Dovelier. Okay, this is R-E-I-N-E-R. Dovellier's law. So at first, Dovelier came up with the idea that he observed what? He observed that certain elements, okay, when analyzed properly, they displayed certain patterns of same type of physical and chemical changes. They have the same similar properties. And now, when he observed even closely, then he saw that these three elements, okay, they have similar properties, and he categorized them into tribes. Tribes means three. So he came up with the idea of tribes. He came up with the idea of what? Tribes. Now, according to him, now if there are three elements and their properties are similar, then you will be able to find the atomic mass. Please remember, atomic mass of the middle element by the help of arithmetic mean, that is average of the other two atomic masses of the elements. For example, now when I give you an example, it becomes more clear. This is an example of chlorine, bromine, and iodine. So atomic mass of chlorine is 35.5. Bromine, we are going to calculate according to this law of tribes, and iodine is 127. Now these are atomic masses, don't forget. We are talking about atomic masses. Now, he told that the atomic mass of this middle element, now these 3. You saw that their properties were what? Similar. Now all of them are what? Electronegative element, and all of them have the valency 1. Therefore, he classified them into triads, that is 3. And according to this law, you know that the atomic mass of the middle element can be calculated by the help of arithmetic mean, that is average of these two atomic masses of these two elements. So let's find what is the value of bromine. So arithmetic mean of bromine, the atomic mass. This is atomic mass, Ag, short form of atomic. Okay, atomic mass of bromine, Br, is given by 35.5 plus 127 divided by 2. Now, whenever you add it, you get so 0.5. You have 7 and 5. 12. So 2, 3 plus 3 is 6. So 162.5 divided by 2. If you divide this, then you get here's 1.25. So with the help of this Doppler's law, we calculated the mass of bromine to be 81.25. which is the approximate value of atomic mass of bromine. Okay, the actual atomic mass of bromine is 80. The actual atomic mass of bromine is what? 80. And with this law, we were getting approximate value of what? The atomic mass of bromine. Therefore, this law was useful at that time. Now, say, with new inventions, with time, what will happen? There are new instruments, new elements were discovered. Therefore, this theory was then discarded again. Now, someone else came up with another theory, which were more relevant at that particular time. Now, this law, the reason for discarding the law of triad is because one. This law we are discussing about reason for discarding law of triad. Why was this law discarded? Reason for discarding this law. This is reason for discarding the law of triad. Now this law was discarded because this, in the way in which he categorized these different elements into three, was not known for all. See, it was not accepted for all. It failed to arrange all the known elements at that time into law of triad. So what point is, the first point is, it failed to arrange in triads. Okay, it failed to arrange the known elements into triads. Number two, even this law was not this law was not even applicable fully for the same group. Okay, like we had discussed about this just now, chlorine, bromine, and iodine. Now, if you say chlorine and bromine, this chlorine's atomic mass is 90. Now, chlorine we are going to calculate according to this, and bromine is just now we saw it is 80. Now, you know, in today's its actual atomic mass is 35.5. Yes or no? Now let's calculate according to this law of Wright. Atomic mass of, say, fluorine. Okay? So it has to be 19 plus 80 divided by 2, which is 199 it is 99 divided by 2. This is only 99. So here it comes out to be 49.5. So you see, this law, according to this law of Wright, you get atomic mass of fluorine to be 49.5. But you know the actual mass of fluorine is what? 35.5. Therefore, this law failed. Okay? So, now, because this law failed, there was another theory. Okay? Another law given by any other scientist. And that law we are going to discuss now. That is known as what? Newland's law of octaves. We are going to discuss about the next law, which is known as Newland's law of octaves. So the next law is what? Newland's law of octaves. Now, according to this law, what we can see is like musical note. You know about musical note? It has 7 notes. That is sa, re, ga, ma, sa, re, ga, ma, pa, dha, ni, pa, dha, ni. So it has how many notes? 7 musical notes. This is known as what? Musical note. And how many notes are there? 7 notes. Now, according to Newland's, he told that when elements are arranged in increasing order of their atomic masses, remember atomic masses. Okay? When elements are arranged according to their increasing atomic masses, the eighth element, okay? The properties of every eighth element starting from any element are a repetition of the properties of the starting element. So in a simple word, he told what? That whenever you are arranging elements according to their increasing atomic masses, then what will happen? The eighth element has to come in here. That means the property of the eighth element and starting element, they will be having the same properties. For example, this is hydrogen, helium, and remember noble gases. Whenever this law was given, noble gases were not discovered at that time. Therefore, hydrogen, helium was not discovered. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Then again you came with fluorine here. Then sodium. Why? Because noble gases were not discovered. Sodium, magnesium, aluminium. Then you have silicon, phosphorus, sulfur. Okay? Then again you have chlorine and you have potassium, and in this way the elements were arranged according to their increasing atomic masses. And you can see that let's take hydrogen. Let's take this lithium, okay? For example, this lithium we have taken as example. Now suppose this is the first element. We are considering any first element. It could be hydrogen, lithium. Now corresponding to this, the eighth element, they will be having what? They will be having the similar chemical, their properties will be similar. So this first, second, third, fourth, fifth, sixth, seventh, eighth. That means this is the first element and this is the eighth element. So according to him, these two, first and eighth element will be having always what? Similar properties. And this law is useful. Why? Because it talks for the first time about the periodicity of the elements. And suppose you are considering, say, carbon. This is the first element. You count first, second, third, fourth, fifth, sixth, seventh, eighth, and this is the eighth element. And these two, we told that these two will be having the similar chemical properties. In a way, he was the one to give these elements, arrange these elements in certain pattern, that in certain groups. Yes or no? So you can say certain problems, they are having similar chemical properties. So, and remember, at that time, noble gases were not discovered. So let's discuss about the merits of Newland's classification. Now, merits of Newland's classification is that this law worked very well for what? Lighter elements. Okay? It worked very well for lighter elements. For example, lithium, sodium, potassium, he placed under the same all, and he told that they will be having the same chemical, their properties will be the same, which is absolutely true in today's modern periodic form itself. Yes or no? So it worked very well for the lighter elements. The second point is, for the first time, it relates the properties of elements with atomic masses. So he arranged elements according to increasing atomic masses. Please don't forget. Okay, he was the first one to give it. And it also showed there is a distinct periodicity in properties of elements. Yes or no? He told that after arranging elements in increasing atomic masses, now what happened? After a certain point, there is a repetition of elements and their properties will be repeated. Now this is known as what? Periodicity. And he was the first one to talk about the periodicity of elements. Now, as you know, as I told you, with modern discoveries, new inventions, then they come to learn more about the elements. And after the discovery of noble gases, what happened? This law was given before the discovery of noble gases. And after the discovery of noble gases, again, it had to occupy some place in this series. Therefore, it has certain shortcomings. Now, the reason for discarding this law is it did not work very well with the heavy elements. It did not work well with the heavy elements. Reason for discarding this law. Discarding of which law? Why this law was discarded? Which law? Newland's. The first one is what? It did not work very well with heavy metals. Work well with heavy elements. Number 2, cobalt and nickel. Cobalt, CO, and nickel, Ni, were placed in same slot. They were placed in what? Same slot, and they were placed along with what? Chlorine, bromine, and fluorine, which have very different properties. So these two were placed in same slot along with fluorine, bromine, and chlorine, which they have what? Different properties. Therefore, this is one of the reasons. And the number 3rd reason for discarding this law is iron. That is Fe. Fe, which is similar to cobalt and nickel was placed far away from these elements. So iron, transition element, So you will come to know that iron, which resembles its properties are similar to cobalt and nickel, but according to Newland's theory, this iron was placed far away from what? Cobalt and nickel. Now, this was the reason why this law was discarded. Now, so with this we come to the end of today's class. In the next class we will be discussing about Mendel's law, and then we will come to the modern periodic table. So till then, take care. Thank you.